Alright guys, this is what I'm going to be showing you today. This is the end result of just creating a very simple schematic. What you have here are just the basic elements of what's going into the install on this 2003 Jeep Wrangler. You have just the battery, which is the battery in the Jeep. You have a fuse. You have a switch. Now this switch is a toggle switch that also includes an LED indicator. So we actually have 3 pins. So 1, 2, or excuse me, 1, 2, and 3. And then finally, I'm representing the 2 lights on the Jeep, going to 2 separate locations on the windshield as one diode LED and another LED. Without these little lines, it would be a diode, but in this case, because it has those lines, it does indicate that it emits light. That's pretty much the same kind of idea. This is more like a black box. There's some other circuitry in here that makes the LEDs work, but I will not get into those details today. So I will show you basically how to make one of these schematics just so you understand how everything goes together, how to make the connections. Let's start with a new sheet. First thing we want to start with is a battery. I'm going to be using the add command. And I'm going to throw in one of these very basic. So it doesn't really matter what the footprint is in this point. This is the symbol. This is what we're most concerned with. And then this is actually the footprint that would go on a printed circuit board. In this case, this is just a schematic only. So I'm really only interested in the symbols. So let's use one of these. This one's good. This is the battery. This is the battery of the vehicle. And in this case, my methodology is I'm going to be running 2 pairs of wires. One is the positive and one is the negative from the battery or the battery junction box to whatever I'm powering later on down the road. Another important note is I'm just going to use the smash command here, and I'm going to delete. So if I can do delete command, I'm just going to get rid of the name of that part. It's not relevant in this case. And then I'm going to be doing the net command. I actually have it hooked up to a shortcut. So whenever you see me lining down these green wires, it's because I've actually hit the shortcut on my keyboard. The next thing we want to add is a fuse. Or we want to add, and then we want to find a fuse. And I typically, at least for these purposes, I'm going to actually use a fuse symbol rather than just a little rectangle. And the only other thing we want to make a note of here, so we can actually add some text, and I'm just going to say 5 amp fuse. And then because this is actually showing up in the net layer, so I actually want this to be in the info layer. Just for reference, just so you know, just so you see, okay, hey, this is a 5 amp fuse. Another thing we can actually do is name the nets. So when your designs get more complicated, you definitely want to name your nets. And when you start actually laying out circuit boards, it's much easier to deal with a net that's named rather than something called an $5. I'm going to call this guy 12 volts. And then I'm going to actually show the label. So it doesn't automatically show the label, so you're going to have to do that yourself. And then again, down here, I'm going to call this guy ground, and I'm going to throw the label on like that. Okay, next step is to show the connection to the switch. So we have typically these wires are as a pair, so they should really be closer to each other if possible, just to show that they are indeed a pair. And this guy can be closer because this guy will be very, very close to the junction box or at the battery itself. And then there will be a second set of wires that will go and run to the inside of the vehicle. And right there, I'm just moving all these guys. If I'm moving too fast for you guys, I am using the move command. It's just set to a keyboard shortcut. And if you're interested in actually setting those keyboard shortcuts, you can go to the Assign tab, and I can actually show you all the things that at least I have set right now. These are kind of drilled into my brain. I automatically start using them that way. So feel free to copy or feel free to change it up, see what you like the best. So now I have these guys. I'm actually going to name the second net here. This is 12 volt, and I'm going to call it fuse. Yep, and then label. So now this is a good representation. Okay, we have a pair of wires going out. This is going to be meeting the inside of the cab. Actually, we can draw out like a little line if we want to here as like an info line. And then we can add text. And we can say, what can we call this? Well, we can call this inside engine bay. All right, now we have the most important part here is the switch. So I'm going to add that switch that you guys might have seen before. It's actually a description of a switch in an LED. Doesn't really matter what the footprint is. Again, the symbols to the right here, we don't really care. This is what we're interested in here. So I'm going to make that connection, and then we have the switch. It's just a representation. It's not exactly the same circuit, but it's close to the idea of what you want to get at. Now, what I want to do here is I want to connect this guy this guy is actually technically internally connected to the output here. So when you turn on the switch, it turns on the LED. Then this guy actually feeds back into here. Now there's a better way to organize it. A more sane way to do it is to just do vertically. And what I'm doing is I have on my mouse here, my right mouse button, I think this comes pretty standard. It actually rotates. So I can rotate my parts to get it in the correct orientation. Typically in a schematic, your positive voltage level is always going to be at the top and your ground is always going to be at the bottom. So if I have an integrated circuit or a box, something like this, your voltages, your positive voltages are always going to be at the top and your ground's always going to be at the bottom. And typically these guys, these ground can actually be replaced with a ground symbol. I will drop that ground symbol on here, but the actual let's close that. There we go. This is actually symbolic, and it's important to know that this is actually a pair of wires rather than just a random net. We're not going to be wiring into the chassis. We're going to be wiring with the two pair or a single pair of wire. Now, all right, we've gotten to the important parts here. Now this is again, this is going to be running as a pair. So we're going to be taking this guy and run this as a pair. And we're going to be taking this guy and running this as a pair. So there's an important thing to note here is that these green dots here actually indicate the junctions. So you can see this guy's running through here, but they're actually not connected. So if I highlight that, they're not connected. If I highlight this guy, these guys are all connected. Very important. If you have a junction someplace where you don't want to have a junction, make sure you fix it. If you want to be connecting, let's say if this junction is not here, if I just say, oh, cancel, or like that, it's not connected right now. So if I just go to info, or if I actually go to the show command, this is actually the show command, they're not connected. So it's important to, number one, use the net command, and also make sure that you're making the proper junctions. Again, this is just for representation. I'm not going to be actually doing this a whole lot here to actually show all these extra connections. They are often substituted by a single net representation, or there's actually VCC representations, which is basically the opposite. It's an upward facing triangle. I would actually put that here, connect all these individual components. Now, what we want to do finally is I want to add a couple LEDs to show that we have the final piece of the puzzle. And all I want is just a single LED. Doesn't really matter. Doesn't really matter. And like so. So again, this is representing. This is actually. I can put another wire or another divider here. This is actually outside on the windshield. So again, this is the ground. So we want the grounds to actually come down over here a little bit. And then the other one just like that. And then we can bring this is the power from the actual switch. Bring this up. Bring this up a little bit too. And then I'm going to add a text. I'm going to call this windshield. Again, we want to change it to the info layer. All right, I'm just going to make that a little bit longer. So we have the windshield, the engine bay, and the inside. We have the switch. Now the only thing we're actually missing right now is the fact that we have the JAE switches, or the JAE connectors. So I'm actually going to see if I can add right now I'm searching for a header because they are a perfect representation of what we have here. I'm not going into crazy. Perfect. So what we have is a 3-pin header that will match pin to pin, and I'm actually going to delete these connections right for a second. I'm actually going to replace them here. So let's just say pin 3 is the power and pin 1 is the ground. So I'll just bring it like that. Again, pin 3, power, pin 2, ground. Now I'm going to replicate this for the other one. So I'm doing a select here, and then I'm doing a copy. But when I'm doing a copy, I'm actually right-clicking when I do the Command C, or if I do the copy command. So if I do copy group, just like that. Then we're going to rearrange this guy. This guy again is power, so I'm going to run this guy here. Yep, we definitely want these connected. And I'm going to name this guy so we know what it is. So it's 12-volt switch. Label it. Boom. And then again, we're going to be connecting the ground, and then again, we're going to just do this here and here. So at a very bare bones level, you kind of understand what's going on here. We have some connectors, we have a fuse, we have this switch, which includes that LED. So this is essentially the schematic. Let's follow this circuit here. We go through the battery, through the fuse, 5-amp fuse, down here, through the inside as a pair of wires. This pair is a 16 wire gauge pair, and I believe the other ones are 18. So we go in here, we hit the switch. The switch, when it's turned on, will allow current voltage to pass through the connectors, through these pair of wires. Now these guys are individual; they're separate. So one runs to the left of the truck, one is run to the right of the truck. Passes through these connectors, and then these connectors provide that final connection to the lamps that we're going to be installing, and then provides that ground path back. And that, again, that ground path is provided through the pair. We have one 12-volt wire, we have one ground wire. So I'll be sharing this circuit. I'll have it in a PDF format. I'll also provide the raw Eagle files if you guys are interested to take a look, make some modifications, think about your future project. I think this will help you immensely because everything's down on paper. You can actually print this, bring it with you when you're doing the install, and be like, all right, I understand how how these wires are connected. I know what pins on the connectors I need to reference to make sure that I'm actually wiring to the correct pins. Small details will save a lot of headaches. So thanks for watching. Again, you can subscribe to my channel right here, Circuit Dojo. You can also check out the website. Check out the link below because all those files, all the resources that I'm talking about are going to be available there.